Hi there, everybody. Welcome to our webinar today titled Designing Trustworthy AI, the Role of Human in the Loop. Thanks so much for joining us. Before we get started, I wanted everyone to know that we are recording this session today. We will be emailing out the recording to everyone along with the slides to have for yourself, and you can also share it with your colleagues if you'd like. So be on the lookout for that via email in the next few days. And also, our speaker today is happy to take questions throughout the webinar, and at the end, there will be time for Q&A. So if you have questions, please submit them as they come up in the Q&A section of your Zoom webinar panel or in the comment section, and we'll be sure to get to them at some point. So let's go ahead and get started. We'll introduce our speaker for today, Dr. Tim Oates. He is the co-founder and chief data scientist here at Synaptiq with over 20 years of experience in guiding organizations and companies of all sizes, applying AI and machine learning to business problems across industry. Tim earned his PhD in computer science from University of Massachusetts Amherst with a focus in AI and machine learning, and was a postdoctoral fellow at the MIT AI Lab. Thanks, Tim, for speaking with us today. I'm going to let you go ahead and take the presentation from here.
Okay, thanks, Sam. I appreciate it. So before I get into the presentation, I just wanted to say a little bit about Synaptiq. We've been around for about 11 years now. In the very early days, we did just a bunch of fixed price AI machine learning contracts. So a company would come to us and say, hey, we've got this data, we've got this business problem. Can you train a model, right? So 10 years ago, it was all building custom models. And we did a lot of work in predictive analytics and intelligent document processing. And over time, we discovered that those clients often had data that needed to be gotten into shape, moved from one place to another, integrated. And so we started doing more data engineering. And then on the other end of the spectrum, those clients were actually building products that were going to be surfaced either internally or externally and wanted to build user experiences around those. So we've pushed out from the middle, which is doing kind of custom modem development, to including the data engineering side and the experience side. And so now we think of ourselves as doing intelligent products. So with that said, what's the outline? First of all, I want to start out and just say, what is human in the loop? So you can see I've got like the second bullet here is what is HITL, or human in the loop? But I'm going to use that term before we get there. So all it means is you've got a system, there's an AI component. That AI component is typically embedded in some sort of a business workflow. It's making decisions, it's producing outputs, and human in the loop just means I'm going to have a human that somehow exerts a little bit of control over that, right? There are points at which the human can do various things. We'll talk about what those things are, but human in the loop is nothing more than people kind of sitting, watching what's happening with an AI-based workflow and has the ability to intervene. So, but before we talk about that in a bit more detail, we're going to talk about a scaling gap. So lots of statistics out there that say that there's a lot of people using AI, but not many organizations are actually deploying it at scale and getting value from it. And we'll sort of talk about the role that humans in the loop might play there. Once we get past all that, we'll look at where do humans potentially add value? What are kind of the sweet spots for getting humans involved into the process? And then you want to do that in a way that doesn't slow things down. Computers are fast, people are slow. I'd like to think we're still smarter, or at least have better judgment than they do, but we don't want to get in their way. And it's important to maintain trust in the overall system. So we'll look at those issues, and then we'll think about some kind of practical implementation ideas. We'll look at a few example workflows, and then we'll finish up. So as Sam said, I'm super happy to take questions as we go through this. I'm just looking at my screen. I don't see the chat, but she'll definitely interrupt me if something comes up. Okay. So what's the AI scaling gap? There's a study by McKinsey, and I've got a link to it there. But there are lots of studies you can find out there that say essentially lots and lots of organizations are using AI. And the McKinsey study found that 88% of the organizations that they surveyed were using AI in at least one function inside their business. And I think this was sort of internally focused. But they also found that in 2025, only 7% had deployed it and integrated it across the organization. Some are scaling, more are piloting, and even more are experimenting. So the punchline here is that if I adopt AI, if I experiment with it, it doesn't mean that I've actually got an operational capability. and there's a gap between there. Now, I've done other webinars on sort of, ways of kind of addressing that gap. So, sort of looking at your data, getting your data AI ready. Today, we're going to focus on people. Another sort of relevant, interesting fact or statistic is they looked at high AI performers, and they had a way of defining that. And you can look at the survey methodology, but they had people who were sort of or organizations that were making very effective use of AI, and then organizations that weren't quite as effective. And what they found is that people or organizations that are making effective use of AI tend to redesign their workflow. So it's not just we've got this old workflow, here's a back office process that we're doing something with, we're going to bolt some AI onto it, but we're actually going to change the way it's structured. And so it appears that this sort of reorganizing or restructuring workflows is important for getting the best utility out of AI. But it is the case that when AI changes work, it changes sort of where the control points are. And so, one of the places that we're going to think about is where humans might exert some control over that process. Another sort of final statistic from this stuff survey is that those high AI performers also, if you look at what are the things that they're doing, the number one thing, so you've got your high AI performers on the right, and that's sort of light blue, and then the dark color is on the left. And it turns out that 65% of them are defining when model outputs need human evaluation, right? So they see a lot of value in this sort of human in the loop. So what they're doing is they are successfully deploying AI. As part of that, they are redesigning workflows. And as part of that workflow redesign, they're paying a lot of attention to where humans need to play an important role in that. So, and there's a lot of hope in the industry and in academia, I think, that we're just going to build better models and they're going to be better at everything, right? So you can see that in the context of large language models. They're rolling out new versions, OpenAI, Anthropic, Google. New versions are coming out, they're getting better and better. But better models can't fix everything. So if your data is not great, if the knowledge that it's working off of is outdated, if you're getting sort of weird cases popping up, or there's some ambiguity in what you're trying to have it do, and if you're not monitoring, then the system can drift, it can do bad things, and that can have poor downstream effects. So the point here is it's not just about, oh, we need a bigger, better, faster model. You need some other things going on. And so there's this gap between AI capability and production reliability, right? So on the left, you've got this AI capability. We built this thing. On the right-hand side, we really want this thing to be running in production and be reliable and effective. And the sort of thesis that we're going to explore here is that, the human is the missing element there. And so what you need is you need workflow controls and feedback. And one very good place for that to come from is from humans, right? So the idea is that people are going to be minding the gap. That is, if you need to move from a pilot to production, you're going to need to think about this sort of control layer that says, well, when is it okay for the AI to go do a thing automatically? When should we get a human involved? And if a human gets involved, like what evidence should they look at? When should they think about escalating? And then another thing we'll talk about is how should they provide feedback to improve the system? So one important role of humans in the loop is to go, oh, the AI system did the wrong thing here. I know it did the wrong thing because I have knowledge that, or I've got judgments that the AI system can't make, but I can convey that so that the system can get better through time. So the thing here is that this human in the loop, it's not a fallback for bad AI systems. What it is, it's actually think about it as a part of a decision architecture for production AI. So you can't go, well, we'll throw more data at it and it'll get better and that'll fix things. Data will get you pretty far, but humans are going to be critical and especially in certain circumstances. And we'll talk about what those circumstances are. So what is human in the loop? We've got this sort of intuitive understanding. Um, Actually, at the end of this, I don't think your intuitive understanding is going to change much. We might refine a few of the details, right? So I would really say that human in the loop it's a family of patterns, and we're not asking, do we have a human involved? It's not just, yeah, we need a person. but you want to know where they're involved and the role that they're going to play. So humans can do lots of things. They can just kind of sit and watch, right? So as the AI system is running, I can kind of keep an eye on it and pay attention and see if I see anything weird happening. In some cases, in critical situations, if there are legal ramifications, so think the legal industry or medicine, you might want to approve before the system takes an action. Like, let me send this up to a human and have them take a look at it. You might want to escalate to a human. So it is the case that many machine learning systems, large language models are getting better at this, but they're still not great at it. They can go, well, I think I'm a little uncertain here. So if this appears particularly risky, or if the AI system is uncertain, you can escalate to a human. As I said before, a very important role of the human is to teach. So the human, as they're monitoring or they're approving or sort of providing other kinds of decision points, then that information can be used to teach the system, to provide data that the system can use in a variety of ways to get better at its task. And then finally, humans can codify rules, right? So I'm going to specify how you're supposed to behave, things that you can do, things that you can't do. We've seen patterns before where people exert influence over, hey, the AI system, you can do these sort of things that are low risk, and we'll talk about that in just a little bit. But if it veers into this territory where a company might get in trouble legally or ethically, we need to have a human take a look at that. So the idea is that humans can intervene kind of before, during, or after an AI takes action. And part of what we'll talk about today is, how do you sort all that out? So there are three variants of this. I've called it human in the loop, but you'll hear about human in the loop, human on the loop, and human out of the loop. So we'll talk just briefly about those variations. So human in the loop typically means that a person is going to intervene before an AI action takes place, right? So, like, there's a workflow, and I'm sitting right here in that workflow loop, and I'm sort of a blocker as a person. And that's important if there's a lot of risk involved. If you're surfacing something that's going to be available ex or visible externally, if things are ambiguous, or, again, if there's sort of regulations involved. So, if I'm a lawyer and I'm writing a legal brief and I get the AI system to help me, it's going to produce the text, and I really need to review that. We've all seen the news stories about lawyers getting, yelled at by judges for producing briefs that had made up case citations, right? Now, and again, so that's sort of like the workflow is processing, and the it hits a wall when it gets to the human, and the human does something, and it says, okay, we can continue, or we need to make a change of some kind. So human on the loop, on the other hand, is that the human is just kind of like sitting there watching. So the AI system is doing something. There's a workflow that has a lot of volume, and again, we'll dig into this in just a minute. The speed matters, right? We've got to grind through all these customer inquiries really quickly, and the risk is like, it's not horrible if the AI does exactly the wrong thing. So in this case, the human is just going to sit there and monitor. They're going to like audit. I'll look at log files eventually, and if I see something weird going on, I'll sort of go deal with it. And then you can just have human out of the loop, right? So the AI can act automatically. But as I said before, the role of the human is to govern and constrain. So if you can put guardrails on the thing and say you're only making decisions in this kind of space, and within that space you are comfortable with it, then if they're low risk, if they're very clearly defined tasks, if you can sort of, if the wrong thing happens, you can go back in and fix it, right? So they extracted the wrong thing for a field. I can go back and go, oh, let me just go find the right data to put it in there. So in, on, and kind of out of the loop. So, one way to think about this is that there's a spectrum, right? So we talked about in, on, and out of the loop. It's slightly more complicated than that. But this graphic just shows, hey, on the top row, the AI can do stuff, and on the sort of bottom row, like, what's the human doing? So, for example, an AI could make a suggestion that says, oh, I think you should write a blog post about this. And then the human does the writing. The AI could say, oh, we should write a blog post about this. and here's the text, in which case the human is going to be an editor. AI systems can make recommendations. They could say, I think this particular case of potential fraud is actually not credit card fraud, it's something else, and then a reviewer could approve it or not. Sometimes what happens is you're in a situation where the AI is making lots and lots of decisions, but again, this sort of idea of uncertainty comes in, and the human is just there to handle the edge cases. Going further, the AI is just doing stuff and the human is watching. And then in cases where the AI is acting autonomously, what happens is the human is the governance owner, right? Like you can act autonomously, but only within this box. So there's a spectrum, and sort of where you sit on that spectrum depends on lots of factors, some of which we've touched on, and we'll sort of touch on those in a little bit more detail in the next few slides. But again, what you're trying to do is this sort of balance, right? The beauty of modern AI systems is that they're remarkably capable. They can do a ton of stuff. You don't want to get the human in the way. You want to figure out where on this spectrum do I live, and can I give the human the appropriate decision authority without bugging the human too much, right? So let's go sort of in, on, and out of the loop. So at this point, it's probably pretty clear that when the human is in the loop, right? So I've got the little icons over there for sort of legal and medical decisions, if those decisions have high consequences. So it is the case that modern AI systems are really good at, for example, reading radiology reports. I can look at these things, and they're as good as humans these days in terms of saying, yep, that's a tumor or that's not a tumor. But it really is the case that you need a human expert to go and invalidate it, right? So AI systems might do things like 100% not tumor. I don't know, 80% not tumor. Let me give that to a human because it's very important that you get those calls right. When things are ambiguous, that where a judgment call is needed. So think about the kinds of things CEOs do, right? I think CEOs and companies are always making decisions where it's like, oh, like we got, we're trading things off. But there are lots of other decisions that happen in workflows where, it's not entirely clear you could go direction A or direction B. And what you really need is you need some context, some experience in making those kinds of decisions that humans can help with. If workflows are regulated, if you've got weird, sort of unusual cases, or again, in particular, if you're doing externally visible communications, I certainly know companies that are doing email campaigns where parts of it to potential customers, where parts of those are AI driven. But there are many cases when you send something out that's going to be visible to the external world, you want to make sure that a human is validated. So, for example, you might have an AI draft a legal memo and an attorney approves it. An AI is looking at a fraud case and says, oh, I think we should investigate this, or I think it's not fraud. And then an investigator is going to make a decision. Or an AI might summarize a medical record. That happens a lot these days. And then the clinician is going to go, okay, yeah, I trust that. I think that's a good decision. Human on the loop, on the other hand, is best when the workflows are very high volume. So think about customer service or document classification. And the decisions don't have a whole lot of risk with them, right? So if an AI disposes of a customer service complaint incorrectly, the customer is going to maybe come back and complain harder, in which case you can escalate, you can reverse it. If your systems are very kind of well-known, mature, and stable, and again, if they have clear escalation thresholds, those are great places for human on the loop. The bottom line is sort of lowish risk, tends to be high throughput, and the system is like reliable, and you understand how it works. So AI systems might route support tickets and you just monitor quality. An AI might approve routine claims, medical claims, for example, but exceptions are escalated. Or an AI classifies a document, and a human's just going to like look at a few of them. I'll even pull a few documents out of here and see how it did, and try and figure out if it's kind of gone off the rails. And then the human out of the loop is sort of like the boring case, right? But the idea is if like no risk, routine, it's reversible, governed by clear rules. So we're doing record deduplication, or we're routing routine tickets, and we've got a ton of data, and it's also the case that I think, though I haven't mentioned it, I believe that sort of the the level of determinism is important. So you know that language models, if you ask them the same question on different days, you're going to get very different answers out of it. You know, automatic routing of routine tickets, the people have been doing that forever using much simpler models that are trained up on large volumes of data. They're like very good. They might have measures of uncertainty, but if they give you an answer and it's above a certain confidence threshold, it's going to be right. So human out of the loop. We're not going to talk about that too much more. So where do humans actually add value? I think there are kind of four key questions. So if you need to know, is this thing right? So it can help with accuracy, but you also need sort of access to evidence. So, human can go, yeah, this seems like the right thing. Another is it appropriate? So is the context correct? For example, we've definitely worked with legal firms and part of not IP, but part of the thing that makes legal firms effective in certain domains is the way they write, the tone, how they say things. And apparently, law firms will protect that. And so it's important that if an AI system is drafting interactions with clients, for example, then they need to be written in a certain way. Is it safe? Right? Humans are quite good at going, oh, right, like AI system. I know that this part of tax law changed recently. You haven't gotten that yet. Um, and I know that the thing that you're trying to do is going to run afoul of that tax law. And then sort of what should we learn? Again, AI systems are happy just to grind out decisions as quickly as they can. But we have to take pain to try and find the decisions that they're making incorrectly, push those back in so that they get better at dealing with those kinds of cases or edge cases or things that they haven't seen before, right? So there's again, just to sort of summarize this, and we've got a few slides to kind of go through it. There's judgment, and for me, this is a really big one because AI systems know what you've told them. It is the case that modern LLMs know an enormous amount about almost everything, but they might not know, or they're not going to be aware of the history of your particular workflow, your company, your work situation, the matter that they're working on. And so humans are good at interpreting context or just having access to context, dealing with ambiguity, and kind of thinking about how you manage trade-offs. So human judgment is a place where you can have a lot of impact. Risk control, again, I think, risk for AI systems is usually I'm going to take the probability of being wrong and multiply it by the cost of being wrong, and you get this number which is very like I know what that number means, but again, it might not be taking into account all the factors. So humans are great at trying to stop actions that might cause harm or that might be expensive to kind of unwind and deal with. Then exceptions, people are pretty good. So humans are good at kind of muddling through life. I've I think about one time I traveled to Japan, got dumped off at a bus stop at midnight, nobody was around, and I tried to had find my hotel and nobody in that town spoke English. That was, I got there obviously and I got back. That was years ago. But people are really good at handling weird, unusual, uncertain edge cases. Computers less so. And then finally, learning, despite the fact that the models are very capable, people can say, hey, I'm going to correct you. And then the system can be built such that those corrections turn into system improvements, right? So think about it this way. You've got risk and kind of ambiguity. So if the risk is low and the ambiguity is low, boom, we can automate it. If the risk is low and there's some ambiguity involved, we can have humans assisting. If the ambiguity is low and there's high risk, then we might want to monitor that thing. Like, it looks like we can tell the machine what it needs to do, but we need to kind of pay attention because we don't want one of those, tumor cases to go undiagnosed. Or if it's risky and if it's risky and ambiguous, then you might need human review, right? You might need a human in the loop who's actually looking at things. So again, think about these two axes of how well defined is the thing and then how risky is being wrong about it. And that can kind of tell you where you live in terms of the level of human involvement that you need. So I want to spend just a minute going through those sort of four zones, right? So judgment, I think when I look at it, it's like when does context change the answer? So human judgment can be based on all kinds of things. I've got history with a particular customer. This customer is grumpy, or this customer is really important to us, and we need to make sure that they're happy. What's the business context? Are there ethical trade-offs that are involved here? And maybe there are other objectives. So I don't know, it's the end of the quarter and we really need to close these deals. And so maybe we're willing to discount more than we normally would, for example. So there's all kinds of things that can be going on contextually that changes or could impact the answer. So, should we refund this customer? Like, is this contract clause acceptable? People are using LLMs to look at contracts, and I know somebody who runs a company, and they just go like, okay, hey, language model, here's this new contract. Is there anything weird in here? And does this employee has raised an issue? Do we need to escalate it? Is this something that we should, go to HR about? So these are the kinds of things that if I pose these questions to you, you would have to think hard about them and human judgment can really help in those cases. So exceptions are like when the system might know it's wrong. So these systems again are depending on which one you're looking at are okay with sort of estimating their confidence, but they might see conflicting evidence. There might be some data that's missing. Um, there's some edge case where like, I don't know, that wasn't part of my training data. You're asking me a question that I don't really know the answer to. Dealing with exceptions is again something that people are quite good at. So, a document extractor can't find a required clause. Like you tell me I've got to extract the name of the company that we're thinking about partnering with, but I can't find it anywhere. Or there are conflicting customer records. So I've got Tim Oates at this address, but I've got, you know, two different ages for this person across two different records. What's going on? Or, a fraud detection model goes, I don't know, like this pattern has never seen anything like this before. I don't really know how to deal with it. So those exceptions can be passed up to humans. And then on the learning side, you know, um, it's it used to be the case that everything was sort of supervised machine learning where you would go, here's a here are some bunch of bank transactions. This is fraud. Here's a bunch of bank transactions. That's not fraud. That still goes on, and there are many cases where you get new bank transactions and the fraud detection model goes, that's fraud. And then what happens is, and this happens to me all the time, where my bank will send me a text and go, hey, I see you tried to buy this train ticket in Europe. Are you really doing that? And I go, yes. Um, that kind of information, those sort of labels, the corrected answers can be fed back to him. Even with modern language models, there's what's called in context learning or in context examples where you can just sort of say, hey, here's an example of a thing that you tend to get wrong, and here's the correct answer. That can modify it. But the idea is that this information can turn into golden test cases. These are things that I might test the models on as we're moving forward. And you can provide a lot of information like, here's some text about why the thing you did is wrong, or here is the kind of error that you committed. All of that information can be fed back in to make the models better. And then finally, when bad outcomes are really bad, right? So, lots of articles about not to pick on Tesla, but self-driving cars of a variety of kinds, you know, crashing. Right? It's sort of the canonical example of where AI systems are not doing well. So, in particular, legal exposure, we worked with an HR services firm that provided a chatbot interface. If you got a small company, you don't have an HR department, but you have HR questions, right? So you've got an employee that's moving from New York to California. What do I do about that from a tax perspective? You could go and ask questions. And they were very careful to make sure that their chatbot was answering questions that didn't have big legal ramifications and escalating to humans in cases where they might, right? So am I going to harm customer? Am I going to have a compliance violation? Is there some safety risk? Am I going to damage my operation? So people again are good at making judgments about this seems like it's okay. This feels like it's too risky. Let me step into that particular gap. So um, a couple more things to talk about. Uh, One is, again, computers are fast, people are slow. That's okay. People have advantages that computers don't, but we don't want humans to get into the loop and slow things down. So the attitude you should take, or the approach you should take, is I've got all this AI output. I am not going to have humans look at it all because that's too expensive and not very effective. So what I'd really like to do is to have a system that's going to triage the risk and the confidence. So AI is telling me all this stuff, what's risky, what's low confidence. And then what I'm going to do is take some of that stuff and hand it to a human, right? So the human might sample some of those, they might review them, they might escalate some of them they might block, right? But humans can take lots of actions on those things, but they can't get the fire hose coming from the AI system. You've got to sort of like funnel it down to a stream that the human can handle and do that in a way that's making sure that you are managing risk and managing potential impacts. So again, if it's like a low risk, high confidence thing, then the AI just goes, right? If it's medium risk, then maybe what the AI does is it says, all right, I'm gonna make a recommendation, the human is gonna look at it. If it's a high risk issue, then the human might go, okay, like help me sort of write this thing or help me think about this thing, but I'm going to make a decision. But if it's very critical, then like get the AI out of there, right? So it's the human taking the action. So again, it's a spectrum of things. And then so finally, the last topic is just on maintaining trust. So I would claim that like trust is like an operating property of the system. You've got to maintain trust in the overall human AI team that's performing here. And there are kind of three pillars that I think about. There's evidence, accountability, and learning. So um, you could go, oh, the AI system said, and of course you wouldn't do this, here's a bunch of financial transactions. I believe this is fraudulent and we should block them, right? But if you review it and you don't have access to the right evidence, you're just making a guess. And so in human in the loop situations, you have to make sure that you're providing the right source documents. So what were the documents that the decision was based on? What was the reasoning that went on? How confident is the AI system? I mean, in general, what you have to do is you have to provide enough information that a human can make the decision unassisted, but then also maybe provide some information about how the AI came to that particular decision. So super important that the human has access to the necessary information. And then oversight, actually, sorry, bugging my slide, oversight. The human has to have these abilities, right? So if the human is sitting there watching and goes, "Yeah, I don't think that's fraud. You should let that go through." But if they can't make that happen, then it's just sort of theater, right? And so the human has to be able to meaningfully alter the workflow. They have to be able to approve or reject. Maybe I can override. There needs to be clear accountability. So and time and incentives to review seriously because it is very easy in these situations. And I find myself doing this all the time where, for example, writing code with Claude Code, which I know that's a slightly different topic, but it's an AI system that helps me write code. And it constantly asks me questions. It goes like, do you think I should do this? How about this? Is it okay to do this? Here's a plan for solving this coding task. And I'm just like, yep, do it, do it, do it, right? So the sort of the idea behind vibe coding is just keep going. And so I fall into that trap, but it's got to be the case that the person is incentivized to do the review and they're given time to do it. So very important. And then finally, we've talked about this idea of learning all the time. That is, so don't have the human provide feedback and block an action or edit a document without capturing it and feeding it back into what the system is doing. So, because ideally, you'd like to get the human from sort of in the loop to on the loop to, maybe out of the loop, depending on what the situation is. But what was the correction that the human made? What was the reason they gave for it? What was the rationale? And, capturing that's going to depend on whether it's a language model that you're trying to modify or instruct, or if it's an old school machine learning classifier. But you need to capture that stuff so that you can feed it back into the system and then like monitor for improvement. And again, the monitoring for improvement is critical because it could be that the person is making bad decisions and sending the system in the wrong direction. Okay. So, practical implementations, right? So here's the way to think about it. So this is one slide and it's got a lot of stuff on it, but I'll sort of walk you through it, right? So you've got some AI enabled workflow. It's important, and this is trying to summarize a lot of what we talked about. It's important to think about like what is the AI influencing? So there might be a long workflow and it just touches one part of it, right? So let's look at the entire workflow. Where are AI systems impacting the workflow, maybe at branch points or providing inputs into it? What can go wrong, and what do you want the human to do, right? So, and the what can go wrong is this risk assessment, which is how bad can it be? How, is this thing reversible? And then you can figure out, am I going to review it? Am I going to monitor? Am I going to, be a blocker is the human going to be a blocker in the path? And then where should they intervene in it? So now what you've done is you've said, okay, here's the workflow. Here's, sort of where we should be in this human in, on, or out of the loop, or the spectrum that's defined by that. Once you know that, you can define what the human role should be. And given that the human needs to sort of look at what the AI is doing at this point in the workflow, here's where they're going to intervene. Then you can say, all right, if the human is going to intervene, they have to be able to make an informed judgment. And so we're going to pack up the evidence. So what evidence do we need to hand to the human who is going to intervene at that point in this workflow to mitigate the following risk? And then importantly, you want to capture that feedback, as we just said, I think 2 slides ago. Capture the feedback and then feed that back into the system in whatever way is appropriate for the way the system is structured. And then now you've got this sort of virtuous cycle, right? And so in theory, what happens is over time, the human, their involvement is invoked less often. Okay. So let's just couple of really simple example workflows, two, and then we're on to concluding remarks. So customer support. You got a customer complaining about the widget they bought. It arrived broken. So the AI might go, all right, I'm going to write an email and I'm going to recommend that we refund them. Or this customer is always returning stuff, like they just need to let the customer eat it. The human then can go, okay, well, are there sort of like serious complaints here? Are they asking for refunds? Maybe this is an expensive widget, and we want to make sure that we're refunding the money appropriately. Or if they're threatening legal action, right? So the human is going to do that kind of thing. Again, routing, if it's low risk, then we can just like let the human sample from them or just auto respond, or high risk cases are going to be reviewed. And then the feedback is going to be what edits were made, what were the reason codes, and then also importantly, are we seeing patterns in that? Or is like the AI system is always screwing up widget A but not widget B responses. And the value that you get is you get faster responses, right? So you're sort of automating the ones that you can, and then you get this kind of like nice consistent tone, and the risk is reduced. On document extraction or information extraction and compliance, again, law firms all over the place are doing exactly this kind of thing. You might get a contract, for example. I'm going to extract clauses and obligations and entities, like who are the parties that are involved, and what exceptions are built into it. So the human could then go, oh, okay, well, it looks like you have low confidence on I don't know, the name of the party that you're entering into the agreement with. Or there's a clause here that says, here's what happens in this circumstance, and that circumstance might happen. We need to really pay attention to that. So, if there's missing information, conflicting evidence, the human can review. And then these corrections become this golden data set, right? So now what we've got is we've got a contract and we've got exactly the right information that should be extracted from it. Those can be used as in-context examples for language models or a variety of other things. And here, again, you get faster throughput, right? Through time, you get the human intervening less, and things move more quickly, and you get fewer silent errors, right? And so silent errors are killers, because if the human's not reviewing and you get errors that are coming out, I thought it was party A and party B, but it's actually party A and party C that are involved in the contract. Somebody downstream discovers that, then they start not trusting the output of the system. and then you've wasted your investment, right? Because once people in your company don't trust the AI system, they're going to start finding workarounds and they're going to start doing the work themselves. And it's a mess. Okay. So, what are the concluding thoughts? I think what we want better models and better loops, right? So, I am not saying let's not improve models because we should, and there's a lot of power in that. So, better models can help, but and they create this capability, but I would claim that having humans in the loop is going to create reliability, right? So remember the sort of the gap that we show. We've got capability and we've got sort of a AI or sort of AI adoption and then AI like production capability on the other side. You need both. And so, I would say human in the loop is it's a decision architecture. It's not like manual cleanup, right? It's part of the loop. There's a thing going on there, and you want to inject humans at the right places. And where should you use humans? That's where their judgment is important, where there's risk, where there's uncertainty, or where you can learn by correcting mistakes. And the best human in the loop systems are going to improve speed and trust at the same time, right? So, speed, sorry, trust primarily, right? Because if you have a human out of the loop system that is making mistakes and your customers are getting bad bills because the AI system is making errors, your customers are going to get angry, and then you're going to pull that AI system. So it's got to be trustworthy. But then, because of the learning component, things can get better through time. So, and the last thing I'll say, which I always say at the end of these webinars, is that I think it's also important to find a partner if you're sort of new to this human in the loop idea, or you're thinking about, hey, I might need a human in the loop or on the loop, not out of the loop, right? Then I think finding a partner who has experience in that is going to be super useful. And Synaptiq has certainly done a lot of this work, but I think rolling your own and just kind of trying to figure it out as you go is difficult in this particular case. So, okay, thank you. I appreciate everyone listening. I'd be happy to answer any questions that might come up.
Thanks, Tim. We've actually had a handful of questions come in already, so I will go ahead and get started with them. The first, I manage a software R&D group using an AI-assisted SLDC. Since we need to own the results and products we create, we use human in the loop, focusing in review approval tasks in spec creation, plan, test, code review.
Yep.
In this type of AI-assisted SDLC, humans can easily become a bottleneck. How would you think about applying human in the loop confirmation effectively without slowing down the process?
Right. So that's a huge that's a big question that the industry is grappling with right now. So
Okay.
so what I would say is there is a big drive these days, and actually we'd be happy to talk about. We're doing some of this internally because inside Synaptiq, we're not doing software development life cycles, but we're sort of using AI systems to help us do exploratory data analysis and build models and sort of write internal tools. And so I think the way that humans can be involved in this without slowing things down is on the governing side. So remember, I talked about sort of providing rules and regulations, and here's what you can do. And so a lot of people are putting a lot of effort into specifying behavior. So writing specs. So the human is going to write the spec that says, here's what the system needs to do. Here's how you know whether it's performing correctly or not. And so putting a bunch of effort into that up front then allows you to use the AI systems to also validate whether they're running against the spec. And there are a bunch of tools out there that are starting to appear that will do that kind of thing for you. And so again, and it depends on how critical the software is, but using the humans up front to play the governing role to sort of very tightly define what the software is supposed to do and how it's supposed to behave and how it can be tested is a really good investment because then you can automate some of the stuff that they're doing on the back end. But I will say there's no great answer to that question right now because I think like everybody's grappling with it, and I don't think there's not the canonical answer, but that's sort of upfront, think about the spec, get humans involved in that, tighten that down, and then automate some of that stuff on the back end is where industry is going right now.
Great. So the next question would be, are there any KPIs that have been established to determine the success of an AI-assisted workflow?
Mm. So, right. good question. What I would say, the way I think about evaluation of AI assisted workflows is it's got to start from, kind of what the business problem is. And when I say business problem, I mean that could be sort of an internal back office kind of thing. So, it turns out that we've got our accounts receivables are growing because we're not responding to our customers who are inquiring about their bills, for example. And so the KPIs I would suggest need to be business oriented. So it's not that you're evaluating the AI system in terms of its AI capabilities, right? What you're doing is you're trying to solve a business problem. And so I think being very careful about saying, here is the historical context, here's the pain point, here's the level at which we're experiencing the pain. Now, what we need to do is to implement AI tools to help with those workflows. Has the pain reduced? Now, it's also important to make sure that you're monitoring other kind of business level KPIs. So maybe what you've done is your response time to customer inquiries has dropped by a factor of 10, but your AI system is just sending the front page of today's New York Times to them, right? And so their customer satisfaction is like, why are you doing this? What's going on? So again, I would say focus on the pain point, monitor for that pain point for the pain to be reduced, but then you have to watch for pain in other areas to increase. Hopefully that helps.
Yeah, great. And then last one, unless more come in. Um, what if the attacker gets access to the human in the loop and alter the decision or give false responses?
Right, in an adversarial setting. So yeah, I mean, right. So all right. So what I'm going to suggest is that's like you certainly need to worry about that, right? There are adversarial circumstances in lots of AI technologies, but I would say this is one where you just need to make sure that you've got appropriate credentialing, right? So the human that's providing the feedback has to log into a secure system in your network and you have to authenticate them. Um, and you've probably got lots of other sort of adversarial issues to think about beyond the human in the loop, right? Like make sure the person is credentialed and logs in and two-factor authenticated, and then I would tend to think that you're good to go.
Okay, awesome. I think that's it for the questions for now. And I know that we're about at time. So thank you everyone for joining us today. Really good discussion. Thanks, Tim, for the presentation. As a reminder, we did record this session, so we will be emailing that out along with Tim's slides via email. So be on the lookout for that. And we'll also be sending you an invitation to our upcoming webinars that we'll be having. So be on the lookout for those as well. And thank you again. I hope everyone has a good rest of the day.
All
Bye.
right. Thank you. Bye.